Today we are going to be doing an introduction to trigonometry. The first thing that I would like to discuss with you are the ratios that we use in trigonometry. Now, in terms of these ratios only apply to right-angled triangles. And then we also want to be discussing the reciprocals. So let's go through the ratios. The first ratio is sine, and that will always be opposite over hypotenuse. Our cos is adjacent over hypotenuse, and our tan is opposite over adjacent. The reciprocals are the inverses of these ratios. So cosec would be hypotenuse over opposite, sec is hypotenuse over adjacent, and cot is adjacent over opposite. Can you see that when we look at sine, you'll see it's opposite hypotenuse? If you look at cosec, it's hypotenuse over opposite. Do you see that? Then the next thing that I'd like to discuss with you are the reference angles that we use. Just like in algebra, we have x, y, and z, or we have a, b, and c for our unknowns. Here we use theta, alpha, and beta as references for our unknown angles. Right angle. As mentioned before, our sine, cos, and tan ratios only apply to a right angle triangle. So let's look at this triangle, and let's look at our angle of theta. Theta touches two sides. It touches 5 and it touches 3. So what we always want to do is identify the hypotenuse. Where's the hypotenuse? The hypotenuse is 5. It's the one opposite the right angle. So we can see that the hypotenuse will be 5. So what's the other side that it touches? The other side that it touches is regarded as adjacent. The side that it doesn't touch is referred to as opposite. So let's look at this triangle. There's our theta angle. And we are going to look at the angles or the ratios, sine, cos, and tan. Sine is equal to opposite over hypotenuse. So in the previous section, we've said that theta touches two sides. So it touches the adjacent, it touches the hypotenuse. The one that it doesn't touch is opposite. So that's opposite, that's adjacent, and that's our hypotenuse. So all we need to do is say the sine of theta is equal to opposite over hypotenuse. So that will give me 4 over 5. Cos of theta is adjacent over hypotenuse, so that's 3 over 5. And tan of theta is opposite over adjacent, which is 4 over 3. So before we continue, there are two things that I wanted to point out to you. The first thing is that no triangle exists in isolation. It always exists on a Cartesian plane. Okay? And the second thing I wanted to mention to you was that you might say to me, but we aren't using opposites and hypotenuse. We are using y over r, x over r, and y over x. And that's exactly why I pointed out number 1 to you, in that no triangle exists in isolation. It's on a Cartesian plane. If you look at the drawing to the left, you'll see that that is your x-axis and that is your y value. And that there is your hypotenuse, or your radius, as you might refer to it. Okay, so y over r is the same as o over h, x over r is the same as a over h, and y over x is the same as o over a. So it doesn't matter which method you use, as long as you are aware that there are two possible references. You might use y over r, or you might use o over h. You might use x over r or a over h, and you might use y over x for tan instead of o over a. Both are completely acceptable. So I'd like to throw a bit of a spanner in the works, if you don't mind. I want you to look at the following drawing for me. We've got two reference angles. The one is theta and the one is alpha. The reason I'm asking you to have a look at this drawing is because I want you to be aware that the reference angle can change. So if I look at sine of theta, I need to go and say sine of theta is opposite, which is 6, over hypotenuse. So that will give me 6/10. And when we simplify it, that would give us 3/5. The cos of theta, again, this here is our reference angle now. So the cos of theta is adjacent over hypotenuse, which is 8/10, and simplifies to 4/5. And the tan of theta is 6/8, because it's opposite over adjacent, and that simplifies to 3/4. But what if I were to change my reference angle and say, let's look at alpha? The sign of alpha is that's opposite, and that's the hypotenuse doesn't change. But now that's opposite alpha. Remember, opposite theta we had 6, but opposite alpha we have 8. So the sign of alpha is 8/10, which simplifies to 4/5. The cos of alpha is 6/10, which simplifies to 3/5. And the tan of alpha is 8/6, which simplifies to 4/3. What do you notice? You should notice that cos of theta and sine of alpha is the same. And the sine of theta and the cos of alpha is also the same. So that's the end of our introduction. I hope you've enjoyed listening with us, and we'll see you again next time.